Water molecules form hydrogen bonds with each other, and right now I'm going to compare water with the gas methane, because these two substances, water and methane, have very different characteristics, and this is due to the fact that water is able to form hydrogen bonds and methane does not. So over here what I have is, I have built out of Lego, that's supposed to be methane and this is supposed to be water. Let's label this first a little bit. In the center over here, we have a carbon. We have 4 hydrogens, hydrogen over here, hydrogen over here, a hydrogen over here, and a hydrogen over here. That's methane. It's the formula is CH4. And over here, on the right side, we have an oxygen over here of water and 2 hydrogens. Now it looks a little bit, actually it's wrong, because it looks like it's a linear molecule, but it's not. In reality, there is an angle between the water and the oxygen, the hydrogens. So actually, I should have drawn this better. You know what? I'm just going to erase this here again. Okay, and I'm simply going to draw the angle, the bonds like this. Okay. Okay. In the next edition, I'm going to improve on that. But it's really important that there is an angle over here. And in a previous video, I already mentioned that water is able to form hydrogen bonds with each other. And now let's have a look how this influences the characteristics of water and of methane. So let's summarize this a little bit over here. Hydrogen bonds form between hydrogens and oxygens of 2 different, in this case, water molecules. Now, hydrogen bonds can, of course, also form within a molecule, for example, in proteins and so on. Hydrogen bonds can be so-called intramolecular bonds as well. But right now, we're not talking about peptides and proteins right now. We're talking about water. The hydrogen bonds are somewhat weaker than the covalent bonds, and therefore they can break and reform, and therefore water is liquid between 0 degrees centigrade and 100 degrees. And water molecules form hydrogen bonds and methane does not. Okay, now, and this basically means, in very simple terms, that water molecules like to stick together because of these hydrogen bonds. And now, what does this mean? Now, let's have a look at this table down here. The property over here is the melting point of methane and water, the boiling point, the specific heat capacity, and the latent heat. I'm going to explain these two here later on a little bit. And then over here, we compare methane and water, and then I'm going to explain why this is the case. So first of all, methane melts at minus 182 degrees centigrade. This means it's going to be really cold for methane to be liquid. And everything which is warmer than minus 182 degrees centigrade means that methane is a gas. And water melts at a relatively high temperature, 0 degrees centigrade. That's pretty warm. I know you don't think it's warm when it's 0 degrees outside. Some of you might think so, it depends where you live. But essentially, water has, compared to methane, a relatively high melting point. It goes from ice to liquid water at 0 degrees. And the reason is it takes a lot of energy to break these hydrogen bonds. So water has a high melting point. Well, if I just look at my own table right now, that's not a really good explanation. It's just a description of what I've got over here. But the reason is it takes a lot of energy to break the hydrogen bonds, and therefore it melts at a higher temperature. Now, although the boiling point is quite high, water has a high boiling point because it takes a lot of energy to break these hydrogen bonds. If you compare it to methane, if you go from at minus 160 to 100, that's 260 degrees difference. And now I just realized that I actually told you something wrong, and I don't know if you were able to catch my mistake. I think I told you before that essentially methane goes from minus 182, everything which is warmer makes methane a gas. That's not correct. This is the transition between solid methane and liquid methane. Of course, methane can also be frozen and be hard, and that's when it's colder than minus 182. So that is basically the mistake that I actually made just a few minutes ago. And over here, we talk about the transition between liquid and gas. Now, the specific heat capacity is also much higher in water than it is in methane. And the reason is first of all, what is specific heat? Basically, this means it takes a relatively high amount of energy to change the temperature of water. So this means that water likes to stay at its current temperature. And this again is due to the ability of water to form hydrogen bonds. And so water likes to stay at its current temperature. If you basically heat up water, then it likes to stay hot. And if you cool down the water, then it also likes to stay cold. That's basically the simple explanation. The more correct explanation would be that basically a lot of energy is needed for changing the temperature of water. And latent heat is also much higher. Now, what does latent heat mean? When you evaporate water, then essentially it takes away heat energy. So evaporating water cools down. Where does this energy, I mean, you've probably realized this after having taken a shower and you go out and then you kind of feel cold. And that's also the reason why humans, for example, sweat, because the evaporating water cools you down. The question is now, why does it cool you down? Because by breaking these hydrogen bonds, by going from liquid to gas, energy is needed, and this energy is the latent heat. And this is basically the thing that cools you down. So, in summary, water has a higher melting point, it has a higher boiling point, it has a higher specific heat, and it has a higher latent heat, all because water is able to form these hydrogen bonds. And that's basically all there is to say over here. These characteristics are really important for enabling for water being the basis for life, so to say. Without water, you cannot have life as we know it, at least. And all of these properties are basically make life possible in the first place. Okay, so that is basically it.